You work for a company that sells paint. You have a new machine that fills paint cans, and you've kept track of the mass of 100 cans of paint that have been filled by this new machine. You want to investigate whether the mass of the cans is approximately normally distributed. The mass of each can is displayed in the table below. The mean of these 100 cans is 3.796, and the standard deviation is 0.097. Note that the data has been sorted for you. Count how many of these 100 cans are within one standard deviation of the mean. Okay, so we need to figure out what the lower bound and the upper bound is for the numbers that are between these two one standard deviation of the mean. So I need to find out what value is one standard deviation less than the mean. So I would take 3.796, which is my mean, minus 0.097, which is the standard deviation. That's going to give me the lower bound of my data. So let's round this to 2 decimals because it looks like all the data here is to 2 decimals as well. So 3.70. So 3.70. And then if I take 3.796 and add to that the standard deviation of 0.097, I get 3.893. And I will round that to 2 decimals as well. So 3.89 is my upper bound for this group of numbers. So I need now to look through all this data and find out how many of these values are between these two numbers. And I'm including the two numbers themselves. All right, so 3.7, I see that in my data set starting right there. And because this data is sorted, I can just highlight row by row until I start getting to 3.89. So there's a bunch of rows of 3.7s, quite a few rows of 3.8s. I just keep highlighting values until I get around 3.89, and then I'll stop at the last 3.89. So there is my group of data values that I need to count. Now, if you count each row, there are 10 values in each row. So right here, I've got 1, 2, 3, 4, 5, 6 rows. So that's a total of 60 values in that group. Then there's 1, 2, 3, 4, 5, 6, 7 here. And 1, 2, 3, 4, 5, 6 here. So 60 plus 7 plus 6 gives me a total of 73 values. Now, the empirical rule tells us that we should expect about 68% of our data within one standard deviation. So this is close. It's within reason. 73 is close to 68. It's a little larger than I would expect, but I don't think it's far enough out of range to say that this data wouldn't be normally distributed. Let's look at the rest. So within 2 standard deviations of the mean. So to get within 2 standard deviations of the mean, I would have to figure out again what those bounds are. So 3.796 minus 2 times 0.097, or I could take 0.3699 minus 0.097. Either way, 3.602 is my lower bound this time, and 3.60 is what I'll round to, make it 2 decimals. And then 3.796 plus 2 times 0.097 is 3.99. Okay, now I'm going to shade in a different color the ones that are in that range. So I know that all the ones in yellow already are between 3.6 and 3.99, but there's more that need to be shaded. So starting with this 3.61, this is now in my new group. and 3.99. So all of those and up to, but not including the 4. So at this point, if I add up how many I have now, and I suppose I'll just use a different color to add, I've got 1, 2, 3, 4, 5, 6, 7, 8 complete rows now, so that's 80. Then there's 1, 2, 3, 4, 5, 6, 7, 8 here. No, 7. And there's 8 down here. So I add that together, that gives me a total of 95 values. And that is right in line with the prediction of the empirical rule. Because the empirical rule says that there would be about 95% of your data within 2 standard deviations. And here there's exactly 95%. And 3 standard deviations. We just do the process again, but go out 1 more standard deviation. So plus 3 times my standard deviation, 3.796 minus 3 times my standard deviation. So 3.51 and 4.09. And at this point, all of these values are in the range of 3.51 to 4.09. So I could get another highlighter color and do that, but I know at this point that 100 of my data values are there. So that means 100% of my data has been accounted for. And that's right in line with the empirical rule, which says that about 99.7% of your data in a bell-shaped distribution is going to be found between 3 standard deviations.